ARP is nothing but resolving the physical address to the logical address. So which is called here physical address means Ethernet hardware address. The address that is imprinted on the network interface card, which is of a 48-bit unique number. So an address can be unicast, broadcast, or multicast addresses. We have seen in the last thing that unicast, broadcast, and multicast addresses. So here, if the broadcast address is that means if the address is all ones, then it is broadcast address. Otherwise, it is you can also mention some unicast address and multicast address, with which you can send to some group, okay, and individually. So mainly this ARP is focused on the resolving of the physical address to the logical address. So physical address is the one which is available at the hardware level, that is the network interface card level. So this Ethernet hardware address is a 48-bit unique number. So if you can observe the Ethernet frame format, so the Ethernet frame format will be like this. So Ethernet frame format is link level connection among the machines is especially dealing with this Ethernet connectivity. For example, if you have two computers, without having any switch or router, directly you can use a RJ45 cable and you can connect to the two computers and you can have a communication only just by using the physical address of two computers. Okay, but if you have more computers, then this is not possible. So link level connection among machines, actually it will be taken by the octet. So basically, you should understand the difference between the address of the physical address and logical address. If you use the IPv4 at the network layer, then it is 32-bit address is there. If you use the why in case of the physical address is a 48-bit address that is imprinted on the network interface card. Okay, 48-bit address that is. Now, so here octet we are going to see. We will see that frame format of the Ethernet, because the PDUs at the, that is protocol data unit, at the data link layer is said to be frame. So we'll see the frame format now. The frame format will be having like this: a preamble, destination address, 6 octets. 1 octet is equal to 8 bits. 6 octets means 6 into 8, 48 bits. What is the 48-bit unique number? So the destination address, the destination's physical address, source physical address, frame type, what type of frame it is, okay, and frame data. This is what the payload is. This is what the payload, and CRC, which is called a cyclic redundancy check, which is of 4 octets. This cyclic redundancy check is used for verifying whether is there any problem in the data payload or not. Okay, so this is the frame format. Example frame format is like this. Here the destination physical address is 0207 like this. Source address is 0800 like this. Frame type is 0800, which means that it's an IP frame type, IP packet type. So the source, the destination address is like this. Source address is like this, 0800, which is a IP type. Okay, this particular payload should be sent to the network layer, and it is of IP format, Internet Protocol format, and this is the payload which is available here. So this is the way the format will be there. Okay, so if you want to disturb this ARP, which you can disturb the source address or the destination address. So obviously the destination can be tampered, so that if you tamper the destination, then the packet never reaches the destination. Because if the destination address is wrong, the system will reject of taking the frame into or sending the frame to the upper levels. So that means whenever you capture any frame structure via any sniffing tools such as TCP dump or Wireshark. So we'll investigate the thing like this. First, a preamble. What is this preamble means? Preamble means that the sending of some signal, because always the computers will not be in a ready position to take the data. So uh, so in order to make the computers to be alert to receiving of the data, for receiving of the data, we'll send a preamble. It is just like it is just like a VIP is going on the road. So VIP car will be there or VIP vehicle will be there. Before the VIP vehicle, some police vehicles will be there for security, and before after that also some security will be there. So the security who is at the beginning, who is the beginning of the convoy, okay, will make a horn or may blow some bell or siren or something, so that everyone will alert. Everyone will become alert that some VIP is coming and some VIP is going on the road. So like that, this in this particular scenario, this is said to be preamble. In our computer terminology also, a preamble will be there. That preambles will be like this: 101010 like that. That means all of a sudden, on off signals was received by the computer. Then the computer will become alert and will think that okay, some packet or some frame is coming into the system, so we are supposed to receive it. So that is what the thing called preamble means. Okay, so once this, whenever the preamble was received, that means 8 signals were received. Then the next, from the next signal onwards, it will find that okay, the original frame is started. So that is what the original frame here. So that means the computers will not consider this preamble. Okay, this will be used for alerting the computers. So this is the frame format that we have seen now. So ARP protocol, actually, what is this ARP protocol? What address can Ethernet interface card recognize? So what obviously the Ethernet interface card or network interface card recognizes the 48-bit address. It is usually hard coded in the hardware. Whenever they are manufacturing it, they will imprint on the hardware device. That is network interface card. Computer addresses and other using IP addresses, which is created to make internet routing convenient. Once the packet reached a LAN, physical address such as Ethernet address must be used. That means it is just like it is in a simple way we discussed that if any packet has been sent, then it will check for the IP address and the port number, and finally it will reach the destination. Okay, it's fine. But how the physical layer devices or data link layer devices know that this IP address is belonging to this computer? That is a big question. So once the packet reached a LAN, physical address such as Ethernet address must be used to identify the corresponding IP address. So how to find out the Ethernet address? Senders usually have no idea about the physical address of the receiver. They don't know. They don't need to know that also, because how the sender will remember what is the physical address of this sender as a receiver or to or a particular device. It is very difficult for every sender to remember that content, because if you know the address, it is sufficient. Because for example, you are staying in hostel, and you, some of your friend has sent a mail or a post. Okay, that post will be sent like this: your name and so hostel number, hostel name, and the university name and address. It is sufficient for you to receive that. But whenever it receives your hostel level, but they may not write your room number or maybe any other thing. So that is it is nothing but the packet is receiving to the hostel. Okay, there the hostel in charge or hostel warden will look for to whom it has come, and they will, that is the responsibility of the hostel warden or the in charge to make you to make it available to you or to at your room level. So this is what the task will be done by the switches. Okay. So whenever the packet reaches the internal network, that is at the switch level. Now the switch responsibility is to send the corresponding IP address related packet to the intended machine. That is what the switches will do at the data link level. So for this ARP protocol will be used. Okay, for this ARP protocol will be used. So how this ARP protocol will function, that we'll see now. So ARP protocol will function like this. ARP example: mission A wants to send a packet to B. Okay, but A only knows the B's IP address. So A know only the B's IP address. So what it will do is mission A broadcasts ARP request with B's IP address. Now A will send a ARP request out on the network. Okay, A will send a request on the network. So if, for example, if there exists a switch between this A and other computers, so whenever A has sent a whenever A has sent a packet with the B's IP address, then whenever the switch receives it, now the switch responsibility is to send an ARP packet to all other computers with by asking that who is having this IP address. Okay, who is having this IP address? So the computer who is having the same IP address will respond that okay, I am the one with this IP address, and my physical address is this one. So that all missions on the local network receives the broadcast sent by the A here. Mission B replies with its physical address. So mission B will send a reply with the physical address. So mission A adds B's address information to its table. So whatever the table it will maintain. For example, if A wants to know it, then A will maintain it. If the broadcast was done at the switch level, switch will maintain that ARP table. Okay. So the table consisting of the IP address and the physical address. So mission A delivers the packet directly to B. So that in this way the ARP table will be formed. Once you connect the computers to the switches, if you can allot at least if you can spend at least 10 to 15 minutes time, then all computers IP addresses and corresponding physical addresses will be recorded in the switch ARP table. For example, if there is no switch, only direct communication with the system is happening, then system will maintain an ARP cache. In that ARP cache, you will be having the table like that, from which IP address, what is the IP address of the systems that are connected in the same network, and what are the corresponding physical addresses. So this is the way ARP protocol works, and ARP cache will be maintained. And at the same time, ARP table will be maintained at the switch level. So that is the reason whenever if the communication is not happening or any other thing, it is always recommended to turn off the switch for at least 5 to 6 minutes. Then you restart the switch. Then within next 5 minutes, this entire ARP cache will be cleared, and the fresh ARP table will be created by making communication with the computers that are available in the network with the switches. So this is the way. Usually, if some communication mistake were happened, or some communication corruption was happened, then the switches are recommended to restart. The same is the case with your routers also. If the network is not happening properly, or if you are not getting the internet properly, then it is always recommended to turn off this router for some time and restart it. So your things will function properly. The reason is because maybe of some malicious softwares, or maybe of some bloatwares or some other thing, that ARP or that cache in your device may be corrupted, so that you may not get the proper communication. So it is always recommended to turn off and turn on, so that this what you call this communication will go on in the normal way. If you look at the ARP encapsulation, the ARP encapsulation is like this. Encapsulation is, you know it, encapsulation is nothing but whenever you are going down the layers, the related header will be added and will be sent out. So this is the ARP message, and ARP message will be injected into the frame data area, and frame header will be there. So this is the way ARP injection will be done. That is, encapsulation will be done. And we have already seen the ARP example here. In this payload, in this content only, this ARP message will be inserted. And if you look at the ARP packet format, the ARP packet format is like this. ARP packet is of 32-bit length, and each and every slot will be like this. Ethernet address is of type address type 1, IP address, Ethernet header address length, IP header length, operation, sender's Ethernet address, sender's Ethernet address, sender's IP address. So like this, this is the packet structure. So whenever you get the content via sniffers like TCP dump or Wireshark, you will get the trace like this. First Ethernet address type, followed by IP address type, followed by Ethernet address length, followed by IP address length, followed by operation, followed by sender's Ethernet address, followed by sender's Ethernet address, last 2 octets, sender's IP address, first 2 octets, the final next sender's IP address, last 2 octets, target's Ethernet address, first 2 octets, target's Ethernet address, target's IP address. So like that, you will get the trace. Okay. In this, the main thing can be corrupted is sender's Ethernet address or target Ethernet address. Okay. So usually the corruption will be done here. Okay. If any of this address was corrupted, then the frame will become the ARP packet structure will become invalid, because during the verification it fails to verify that that particular packet is intended for the corresponding computer. So thereby, if the computer understands that this is not intended for me, obviously the packet will be dropped. So whenever you make any trace in the sense here via Wireshark or TCP dump, this format you should remember. And we should mainly focus on the we should mainly focus on the fields such as sender's Ethernet address and the target Ethernet address. So these are the 2 main targets. So you must remember these 2 things to target. Otherwise it is very difficult for you to frame the policies in the firewalls and writing the rules in the intrusion detection. Okay. This is what we call ARP packet format. So this is regarding ARP packet format, and there is another protocol along with this, which is called reverse address resolution protocol, called RARP. So the idea of RARP is to map the physical address to the IP address. So the ARP packet is responsible for mapping the IP address to the physical. That is, ARP is responsible for mapping the IP to physical, and the reverse address resolution is responsible for mapping the physical to the IP address. So this is the way how the RARP and ARP will function at the data link level.